Okay, welcome back to our third part. So let's look at what we have done so far in this semester, right? So first, we started studying an economy of pure exchange, right? This is an endowment economy. Then in this economy, we studied the Walras law first, okay? Then we look at the definition of the Walrasian equilibrium. Then we studied three positive properties, okay? Positive properties of the Walrasian equilibrium. So these are existence, uniqueness, and stability. All right. Now, next in our agenda, of course, is the normative properties of the Walrasian equilibrium. But in here, before that, I want you to show you the Edgeworth box economy. Because if we understand the Edgeworth box economy, it will be better, it will be much more easier to understand the normative properties, because we're going to discuss the welfare theorems by using the Edgeworth box. Okay, so for this reason, now I'm going to continue with the Edgeworth box economy. This is straight from your text. Okay, so this is the Edgeworth box economy. All right, so now we have two commodities and two consumers. Okay, in our previous study up to this point, we took XIH as given, right? For now, I mean, in this Edgeworth box economy, we're gonna derive this, okay? So there will be utility functions and constraints of the consumers. So they're gonna take optimal decisions, okay? And using their endowments, they're gonna earn an income in markets. They're gonna sell what they have, and then they're gonna purchase what they prefer. Okay. So let's start with preferences. Okay. So we have utility function. Let me check my notes. So we have utility function of the first consumer. This is defined in this way. Okay, there are two goods, right? So x1, alpha 1, x2, 1 minus alpha 1. Here we assume that alpha 1 is between 0 and 1. Okay? And then we have the second consumer, again consuming x1 and x2. So we have x1, alpha 2, x2, 1 minus alpha 2. And again, alpha 2 is between 0 and 1. So you see, these consumers or households, they are different. In general, they are different in terms of the utility they attach to the first good and the utility they attach to the second good. So these exponents in general differ, but we're going to assume constant returns. Okay. Now, endowments are like this. So the first consumer has E11, E21, okay, and the second consumer has E21, E22. Sorry, E12. It's going to be E12, E22, right? Let me check. Yes. Then we have prices, P1 for the first good, and P2 for the second good. We're gonna look at, of course, the cases of positive prices. Okay. Now, as you see, consumers once again have the same type of utility function, but they differ parametrically. So exponents are generally different. They have endowments of both goods. Okay, but those endowments are in general also differ. And also we have two prices. Now we can write incomes, right? Let me use this space to write incomes. So let's denote income of the first consumer by M1. So we have P1 E11 plus P2 E21. And then we have the second consumer's income. It is P1 E12 plus P2 E22. All right? So these are then income levels. Now, if you think about this problem, as you see, the utility function is Cobb-Douglas. Incomes are going to be taken as given, right? So our consumers solve something like that. Maximize X1 alpha 1, let's say, right? Or more specifically, X11 alpha 1, X21 1 minus alpha 1 by choosing X11, X21, subject to P1 X11 plus P2 X21 equals M1, right? And M1 is again given as P1 E11 plus P2 E21, right? Let's check. P1 E11, P2 E21, okay? And similarly, so this is for H1, the first consumer. A similar problem could be written in the same form for the second consumer. But what do you know? You know that this is Cobb-Douglas, right? So you know the solution, right? I mean, you can solve it, of course, by using the Lagrange technique. But what you know is that a fraction alpha of income, alpha 1 of income, is going to be spent on the first good, and the fraction 1 minus alpha 1 of income is going to be spent on the second good, right? And if we look at the second consumer, we also have X1, 2, alpha 2, M2, P1, and X22, 1 minus alpha 2, M2, P2. Let me check. Yes, so these are now your chi functions, right? This is chi 1, 1. This is chi 2, 1. This is chi 1, 2. And this is chi 2, 2. All right? You should be careful with the indices. Now, we have, when I write chi, I mean chi I, H, right? First in this, first index variable is for the goods. The second index variable is for the consumers, okay? First, with respect to goods. Second, with respect to consumers, okay? So what's next? Market clearing, right? So I want to write total demands. Let me use this space because it will be easier for me. This is very simple micro problem that you always studied. Of course, it doesn't have to be complex. It doesn't have to be that simple, but for now, for this example, we're going to look at the simplest case possible. So what I want to do now is to write total market demand for good 1. Okay, so it is okay, so it is chi1 p, let's say, right? So it will be chi11 plus chi12, right? So I have alpha 1 M1 P1 plus alpha 2 M2 P1. Okay, similarly, so this is for I equal 1, right? And this is for I equal 2. So I have chi21, chi22. Okay, so chi21 is 1 minus alpha 1 M1 P2, and I have 1 minus alpha 2 M2 P2. Okay, these are now total demands. Now, if I want to write excess demands, I have to, of course, look at the supplies as well, right? So total supply of the first, so this is for the first commodity. So the total supply of the first commodity is E11 plus E12, right? First, it is the commodity. Then for the second commodity, I have E2, E21 plus E22, right? Is that correct? Let me check. E11, E12, E21, E22. Yes. So you should always be careful with the indices. Then excess demands could now be written, right? So excess, okay. Excess demand in the first market will be alpha 1 M1 plus alpha 2 M2 divided by P1 minus E1. And in the second market, I have 1 minus alpha 1 M1 plus 1 minus alpha 2 M2 divided by P2, that's total demand, minus total supply. Okay? Now, you have excess demands. Now, be careful. I'm writing them as a function of price, but they actually, if you write them, let me use this space now. If you write them explicitly, they are functions of prices and endowments. Okay, you should be careful because incomes depend on endowments. Oops. Okay, incomes depend on endowments. Now, equilibrium is what? There will be a Warwazian equilibrium, of course. It will be a price vector, P1 star, P2 star, right? Such that zeta 1 P star will be equal to 0 and zeta 2 P star will be equal to 0. So you're going to go look at these equations. So you have two equations, right? Zeta 1P is here, zeta 2P is here. So these are excess demands. These excess demands will be equal to 0 in both markets for us to define the Warwazian equilibrium. All right? Now, if you just do that, you're going to realize one thing. You're going to realize that without price normalization, you cannot solve P1 and P2, right? Because of the Walras law. Remember, for any price, if one market clears, the other market automatically clears because there are two markets here. So we need to provide new information to the system. But before that, before making a price normalization, let's do what we can. Let's see what we can learn using those equations. So if you do the math, so if you take these equations and if you replace M1 and M2 as well and do the math, you're going to end up with this one. You should check this, okay, my friends. So you have alpha 1 M1 P1 star plus alpha 2 M2 P1 star. Okay, this must be equal to E11 plus E12. That's one equation. Then you have 1 minus alpha 1 M1 divided by P2 star plus 1 minus alpha 2 M2 P2 star being equal to E21 plus E22. Okay. And of course, again, M's, M1 and M2 depend on prices and endowments as well. So if you do the math here separately and here separately, you're going to end up with this one. You should do this. That's your another assignment. So alpha 1 E11 plus alpha 2 E12 minus E11 minus E12 P1 star plus alpha 1 E21 plus alpha 2 E22 P2 star equals 0. Okay, from this equation, you're going to end up with this one. From this equation, you're going to end up with something similar. It's going to look like this. So 1 minus alpha 1 E11 plus 1 minus alpha 2 E12 times P1 star plus 1 minus alpha 1 E21 plus 1 minus alpha 2. I'm looking at my notes because I shouldn't want to, I don't want to make a mistake. Minus E21 minus E22 times P2 star equals 0. Okay, so as you see, let me show that to you. As you see, you can easily derive these equations. Okay. Now, After you do that, notice one thing. This is a constant. This is a constant. This is a constant. And this whole thing is a constant. So let's, so you can denote them by A's and B's. So let's say this is A, this is B, this is C, this is D. So what do you have? You have A times P1 star plus B times P2 star equals 0. And you have C times P1 star plus D times P2 star equals 0. Or more specifically, you have A, B, C, D times P1 star, P2 star equal 0. Okay? Now, as you see, this is a linear equation system, but it is homogeneous, right? Because you have zeros there. So if you want to draw it, you have something like this. You have P1 star, let's say here, P2 star here, and so for there is an equilibrium. So first of all, they both cross the origin, right? So this is 0, 0. Let's say the first equation is this. Oops. Is this. So let's say this is P2 star equals, so it will be P2 star equals minus C over D. Okay. Minus C over D P1 star. Okay. And let's say if they are not oops. Let's say this is P2 star minus A over B P1 star. Okay. Now, what do you see? If A divided by B, if A divided by B is different than C divided by D, if these two lines have different slopes, then they only intersect at 0. But this is a trivial equilibrium, right? Because we want to look at P1 star, P2 star greater than 0. Then equilibrium requires that they have the same slope. Or AD minus BC equals 0. But what is this? Remember the matrix. Your matrix is AB, CD, right? So this condition is actually, if you notice matrix X, it is actually determinant of X equals 0, right? In other words, slopes must be the same. So for equilibria, let me use this space. For equilibria, you must have something like this. So the first equation will go like this, okay? The second equation will go like this, okay? So basically, they're gonna overlap perfectly, right? So now, what's going on? You have P1, P2 stars, But then you have an infinite number of solutions, right? You have infinite number of why? Well, because you didn't impose price normalization. Okay? Now, if you normalize prices, if you impose a normalization such that P1 is equal to 1, okay, that becomes your price normalization, then you can find P2 star. Okay? This means because of the Walras law, these two equations, this equation and this equation, okay, they basically carry the same set of information. So you introduce new information. So you disregard one of these equations, you take this one, and then you assume P1 is equal to 1, or you assume P1 plus P2 is equal to 1, or equal to 100. Okay? So that's the idea. You're going to realize, if you look at it carefully, they carry the same information. Okay, in equilibrium. All right, so that's your assignment, going from this to that, this to that. Okay, and then you're going to see how you can construct the equilibrium. It requires that. So then you normalize one of the prices again. You can do P2 star equal 1 as well. I mean, it doesn't really matter. You can assume that. So imagine this. You can also do that. Let's say your market clearing equation is that. So this is market clearing. Okay, and then let's say you make this normalization. This is the price normalization. Okay, then you can still find P1 star and P2. The important thing is that you introduce new knowledge. Okay, that's the entire idea. Now, in the remaining 10 minutes, if you have no questions or comments, I'm going to show you the Edgeworth box. Okay, now let's start with consumer 1. Okay, so consumer 1 consumes X11 and X12, right? So he or she has preferences, right? They go like this. So these are utility functions. So U1 hat, U1 tilde, U1 bar, that goes like this, right? U1 tilde greater than U1 hat, U1 bar greater than U1 tilde. Okay, so utility increases in this direction. Okay, everybody knows that. Now, there's also the second consumer. Second consumer has something like this, right? Now, imagine if I can combine these two graphs in this way. So, this is consumer 1. This is consumer 2. On this direction, so these are directions for consumption of the second consumer. So this is X22, and this is X12. Okay. On this direction, you have X11. In this direction, you have X12. All right. So let's say consumer 1 is red and consumer 2 is blue. All right. So blues will be like this. Let's see if I can do it. Okay, and red ones will be like, okay, the last one is not very nice. Like that, right? Now, what we look for in equilibrium is basically a price ratio, right? Remember, this solution gives you, oops, a ratio of prices, right? Basically, the slope. What matters is the slope. Okay? Now, that slope is found if both people are happy with the exchange. Okay? Let me show you. Let me use green. So you have, okay, let's see if I can do it. Oops. There's this ruler option. Maybe I can use that. How can I do that? Oh, exactly like this. Okay. So how can I carry this? Okay. As you see, I'm still learning. Okay. The slope is nice, actually. Okay. Now, as you see, for some reason, it's not really good. All right. So imagine there is this line, okay? And this line, of course, let me just check. Should intersect with the endowments. Okay? So initially, people have endowments. This is E11. This is E12. So then this is, wait, I have a mistake here. This is E21, not E12. So this is E21. Okay. So here you have E11, the endowment of the first consumer of the endowment of the first good by the first consumer, and this is E21, endowment of the second good by the first consumer. Then you have here E22, and here you have E12. Now the question is this: why the price vector? This is your price ratio, let's say. Why the price ratio intersect with the initial endowment? It's a very simple reason, because they have to sell their endowments in those prices as well. Okay, but guess what happens? So look at the initial case. In the initial case, the blue guy is here. The utility of the blue guy is here, the first consumer. And the utility of the red is here. Okay? So if you compare this to that and this to that, you see that the welfare of both parties increase thanks to the preferences and the exchange. Okay? Maybe I can do this. It could be a better idea because I couldn't draw this very well. So let me stop sharing my screen and look at my cam. Right? So there is this equilibrium right here. There's this price ratio. So utility is maximized for both consumers, and compared with the initial endowments, utility obtained by initial endowments, the equilibrium values are larger. Okay, that's the entire idea of economic exchange. If you want to, I mean, this is, you may imagine that this is Adam Smith, right? This is Adam Smith's celebrated invisible hand. Now we have less than a minute, and this was our third session. So I want you to direct your questions or comments by email. Okay. It's about to end, so I will see you next week. Okay, we're going to continue with the normative properties of equilibrium.
Have a nice day.
Okay. So please direct your questions and comments by email. And I will answer them in the beginning of the lecture or by email to you as well. Okay.
Okay, thank you.
All right. Bye-bye.
Thank you.